And let's look now at the scatter plot. So the scatter plot, unlike the other graphs that we look at, compare two variables at one time. So in this case, what I have is a list of some of the NASCAR races from the previous year. Now, I'm not a big NASCAR fan, so forgive me if I don't know what I'm talking about. But I have the reason I chose it is because the races are different distances, and that means there's going to be a variety of winning times as well as distances, and so we're going to get some variation in our data here. But these two things I have reason to believe are related. And that's what we're looking for, is a relationship between two variables. And so we want to know what kind of a relationship exists between those two variables. And when we plot these things, what's going to happen is we're going to get some dots that kind of line up. And I would expect that as distance increases, so will the winning race time increase, because it's going to take longer to win that race. And we call that a positive relationship. Now, if for some reason the dots lined up and they kind of had this order where as we increase on the x-axis, or the horizontal axis, these values get lower, that would be considered a negative relationship. And if we can't really tell if it's positive or negative, sometimes it's just kind of a big blob of, just dots everywhere, then we'd say there's no relationship between them. And then the closer these things are to a line, to actually lining up, the stronger the relationship. Whereas something like this would have a very weak relationship. And then these are somewhere in between, right? Okay, so what we need to do for a scatter plot, it's kind of all about defining the scales of our graphs. So first thing we need to decide is which variable goes where. This axis down here is called the independent axis. It's also usually called the x-axis, because when we get into algebra and graphing, x is the horizontal axis. Okay, but independent because the distance of the race does not depend on something else. The distance of the race is defined ahead of time. What depends is the race time, or that winning race time. So the winning race time depends on the distance of the race, or at least that's what I'm anticipating. Okay, so once we've got that figured out, okay, I'm going to put distance down here, I'm going to put time up here. Then I need to decide how I'm going to separate off my grid. And for this one, I went ahead and printed a grid ahead of time. So I've decided, since my races go up to 600 miles, that I'd start at 0 and go to 600, and so every 4 blocks is 100. And then my winning times go all the way up to 272. So I went again from 0 up to 300, and I'm just going to fit those dots in there. Now, you can decide later if you think this is a good method, or maybe if I should have done something different, because I think maybe I should have done something a little different with my scales here. But if we set it up like this, then we just look at each of these as an ordered pair. Okay, so we've got an x value of 500, a y value of 203. Now, if you don't want to hear x's and y's, just think, okay, I'm going to go to 500 on my distance and to 203 on my time, which is about there. I'm just going to estimate that, right? Okay, and then we've got 400, and we would go up to 208. And again, there's going to be a lot of estimation of dots. Now we've got the next one down is another 400, and it's going to go to 170. And the other type of chart that we had that had these two axes and we were plotting points was a time chart like this. And you'll notice on a time chart, if we just look at the 2026 data for, I think this was temperature, there was only ever one dot for each of our x values down here, right? None of these two dots ever overlapped each other. But here we can have multiple dots on top of each other. Okay, 312 would be right about here, and we're going to go up to 181, which is, somewhere around there. Okay, 250 and 151 would be right about there. 263. Sorry, I know this isn't the most fascinating content here. Let's see how these dots are lining up though so far. It looks like a kind of just like straight across, but I mean, there's a pattern there. I don't know. Let's keep going and see if anything else comes of this. So this might help. We're down to, let's see, did we do the 263, 200? Yes, I just did that one. Now we've got our 600-mile race, and that goes all the way up to 272, which should be right about here. Okay, and then we've got some shorter races. So 218 and 218 miles, and it took 218 minutes to finish. That's interesting. 300 miles and 186, which is just probably a little higher than that other one there. And then 220 and 184. Okay, so it takes a little time to plot these, but then the idea with these is we would look for one single line that kind of best describes the trend that we see here. Sometimes I think of putting these in like a little oval or ellipse, kind of try to make it a symmetric one. And then the line, which we would call a line of best fit or a trend line, would be the line that cuts that in half. Now, I don't know that I'm actually doing a good job of it, but we'll make a little estimate. So some of these lines are going to go, some of these points are going to go above that line and below it. And not every point is going to be exactly on the line. Maybe none of the points are on that line. Okay. But then we can use this line to make predictions about, say, a race that was only 100 miles. Hey, what if we put together a race that was only 100 miles? How long do you think that would last? And then we'd go up here and we'd go over here and we'd say, oh, somewhere between 100 and 200 minutes. I'd say maybe just under 150 minutes. Okay. And so we can use that to make predictions, which is that third level of reading data from graphs, reading beyond the data, right? Or I could say, hey, there was one race that was 500 miles. How long did it take to finish that race? And then you could read the data directly from there. Okay. Or I could say, hey, are there any outliers on here? And the outliers would be points that are really far from that line. And, you know, these, they don't look too far off of that line, so I wouldn't call them outliers necessarily. There are mathematical ways to find those, but we're not going to worry about that. Now, this again is different than a line graph in that, or a line plot, in that in a line plot we connect dot to dot to dot. Okay, it's not one straight line, it's a bunch of little line segments connected. Here, we're just looking for that trend line or line of best fit to go through them. And then that helps us make predictions. And then we can also talk about what kind of relationship do we have? Do we have a positive, a negative, or is it no relationship? It's kind of hard to tell from this. And I mentioned to you before how maybe I should have done my graph a little differently. So let me show you the other version I came up with. Here's what I did. So instead of starting at 0 and going all the way to 600, since my smallest distance was 200, I started there. And then since my smallest time was 150-ish, I started there and went up. Okay. And the advantage there is we get to spread the data a little bit more. See here, we've got a lot of unused space, all down here and all here. So by doing that, I can spread my data out. Now, I did want to make sure people knew that I did that so it wasn't misleading. So I put in these little wavy parts to say, hey, I'm skipping some of this. Okay. Now, when we look at our data, okay, again, if we put that kind of that oval through it or ellipse, and then let's see, I misplaced my ruler, but you can picture a straight line going through there. Here it is. Right where I left it. All right, something like that. Okay, that's probably not the best, but it gives you an idea of that trend line. Now, we do have to be careful because where that graph would intersect the vertical axis, if it's in this wavy part, might not have much meaning to us. In fact, this doesn't anyway. So if you're looking for something like a y-intercept, which is more higher level things, you would have to graph it more like we did here. But in any case, that is a scatter plot. So we have one variable called our independent variable on the horizontal axis, another variable that depends on this one on the y-axis, and then we plot the 2 points and we look for that trend line, and that is a scatter plot. And then you can see from here, it does look like there is a positive relationship. Now, is it a strong positive relationship? I don't think so. I think they don't line up too well in a straight line, but again, there are higher level equations that could, formulas that could tell us how strong a relationship it is. Right now, we're just interested in, is it positive, is it negative, or is there no relationship at all? And put all that together, and those are your scatter plot basics.